Welcome you all for the presentation in pointers in ADA programming language. Access types are used in ADA language to provide the pointers features, where we see generally the pointers in other languages like C. So the same features is provided in ADA language using the access types. So how do you declare the access types? So access types are declared using the type definition, which you generally see in the ADA language. So this is the declaration for the uh, pointer or access type for the integer, and the corresponding variable is defined here: p people colon and p integer. And the variable which we need to use for pointing is defined as a aliased integer. And how do we assign the value to the pointer or access type is defined in this form: people tick access. And how do you modify the values? So you can modify either to the pointer value or to the variables. Anyone you modify, it will represent the same values. So one small example which will elaborate how do we use the pointer. Like for example, you see here this integer pointer is access. So we are not using access all because we are not using the pointer to local variable here. So this is another way of pointing to the memory which is allocated as a heap or something. So this is the one memory is allocated to the location and the value this is assigned. And if you see here that to print the value, you have to use the location dot all. You cannot use location because this is illegal in this. Whereas this type of printing is allowed in the C language where you can print the values. But you can use unchecked conversion to print this location. One more type of pointer is a constant pointer, wherein you can access the value but you cannot assign the values. So, like you see, the same thing we have declared the access constant integer, and the next the local variable, and also variable for the pointer. And the variable is assigned to the value, and this is assigned to the pointer, and the value is printed people.all. So, if you attempt to assign the value to the p underscore people dot all, this will throw an error compiler because this is defined as a constant integer. So now we have to see three: access all, access, and access constants. Just I given in the table, how do we declare and how do we use? Like you see, for access all, you have to declare access all t and alias and also pointer declaration. And usage is you have to use tick access for the a of t and apt. And for assignment, you use this a of t all. For access constant, use access constant t, and one more is variable here, and you will define you will print the value here access and assignment access. And the next one is which you want to allocate from the memory, you can assign like access t, and next new t and a underscore pt dot all 2 is the value assigned to the some storage location which is not the local declared variable. And how do you define the access type for the records? If you see here, there's one small program wherein you define the one record which containing the name, height, and gender, and this one is accessing person record. So this is the one access type, and the variable for this is defined as an access type, and you are using a new year. Again, the new without using a local variable. If you want to use local variable, you can use a local variable, but you have to use alias for this. And how do you assign the values to this? So another way of assignment is the one way directly you can assign the new person. Another one is new person and assign p mic dot all person mic 183 male. Like this you can assign. So you can also define access type within the record. Like for example, you see an access type of same own record is access defined in the record. So this is used to link many records. Like if you see here, there's a one mic, which is, and the next one is assigned here. So same thing you see here, people dot next is assigned to the next else. You can assign in sequence till the end of this. And the next one is how do you print? Like for example, you assign the multiple things. How do you print? So there is the one way where you can iteratively call your put procedure to print this one. For example, initially the pointer is not equal to null. By definition, it is null. But when you assign some value to this, it is not equal to null. It goes and splits the values, and the next one is assigned to the next one. So this will be looping till the number of records are available in that pointer. Same thing it can be implemented using the recursive method also, where in the recursive method you will be calling the put function, put procedure once again with the value of the next pointer. Like if you see here, cursor dot next we are called to call once again the put. So, generally, if you see in any programming language, we have the problems with the dynamic storage. The following problems are there. The problem is first one is memory leak. Memory leak is like once you allocate the memory to the pointer and you forget to remove that one, then it will occupy the data. Then it will occupy the memory, and you will be running out of the memory if you are forgot to remove it. And you may try to access the same memory once again for different data items. Then this will corrupt, and if there is a chain is broken, then you will not able to see the data properly. Another one is there is a time deallocation. Time to allocate and deallocate storage system is not always constant, because this varies from the one type of memory to the other type of memory, and this figure is to be calculated before using the pointers. So now ADA allows the solution for this in terms of dynamic memory allocation by providing some default implicitly freeing the memory. Okay. Another one is providing the similar to other languages functions to deallocate the memory. Like if you see here, there's a one once you define the type, and if the procedure is coming out of the type, then the memory was reserved for the type is automatically a type or type objects are automatically assigned to the your memory for usage to the program. And you can use the program actually called the store management. Like if you want to deallocate, you can call the deallocate functions to deallocate the memory which is assigned. So this is same thing. Store allocation implicitly managed by the system. So deallocation automatically this thing done, and store deallocation explicitly initiated by that prevents inactive storage consumption program address space. This is the same which is offered in other languages. And the syntax for deallocation, if you want to deallocate, you can use this free function of the unchecked deallocation. This unchecked deallocation you have to use a with this already predefined library is there. Like it is having a two arguments, tree node and tree access. Tree access is the access type for the tree node, and tree node is the data type which you want to use. And where you want to call you have to call it the free bracket current, where the current is the data variable of the tree node type. This provides you to the reallocation memory which is occupied with the pointer. And the other one is function access type. So you can use this access not only to the variables and records but also the functions. So how do you define the functions? Is functions is defined by this parameter. P-func is access function. This is a user defined variable, and this is the function which needs the pointer to be defined. So the benefit is you can use the same syntax for the multiple arguments functions. Multiple functions with having same arguments. Like one more is this is the record which is like a generic record which you can define the variable, and this is the procedure which is how do we assign, like this is the function access type based upon your two values is accessing the corresponding function which is passed to this. And this is just normal function which is square and cube, which is used to demonstrate the function access operation. Like this is a small protein which will demonstrate the how to use the function access pointers. Like you see, this p-func is access function. This is what we defined at the top, and this if you replace the square and float which you defined previously, and this is for put for printing. Now you see numbers. Number is a one vector type which is assigned with the 5 values. Now square list, when we call apply, we are calling it the square access, and numbers. The internally the square access will call the function for the square to call for the square. So it will print the output like this, and similarly you can. So the benefits for using is the different functions are called with a pointer, so that now internally compiler calls the corresponding square and cube based upon the your access call. And this is the benefit for this thing not required to call individual functions, and also the number of times also is restricted. You can just call simply once. And how do you access? Like as we shown in the previously, we use the tick access to allocate the memory to the pointer. And but there is some rules in the ADA which you cannot forbid. Okay, like the rules are like this. For example, this is one more procedure you can take it. This is a top level declaration where you define the access type and also the object for the access type, and you define the what you call allocate the mic access. So the mic is alias the person. Now you see one more Clive is there, which inside the one more declaration block. Where is the P home is the access level 1 and this is access level 2. You can call this is the first access, this is second access. So if you see here, first access pointer is allocated with the second access value or local variables. So this is not allowed in the ADA language. And additionally, you see, since the once you come out of there is no Clive is not there, and you are trying to print. So these things will give the error in the ADA language. So you're not allowed to use because as we understood in the previously, the scope of the P person is as long as the type is existing in the scope. Since the type is existing at the top level, but the Clive is inside. So once you come out of the Clive, there is a possibility of memory leak will happen. So to avoid this, ADA will not allow this type of assignment. However, if user intended to assign this one, he can do by using the unchecked access. So that is given here. So this, if you see here, the same thing they are assigned with unchecked access. So and once you come out of here, then you are printing here. So this is up to the user to ensure that he is assigning properly. So that's why the compiler will not take off checking this proper allocation. So that's why we used unchecked access when it is required. So as I explained, so these access types are used to are avoid our application avoids the uses of pointers or access type when the memory relation has to be known properly and the timing is to be known properly and the mathematical logic. Then only we can use the access types. So some application will not use the access type because of this type of problems. Thank you.